6x minus 10. And again, I'm going to write down all of my different values. So I know that my a is 1 for the third time. This time my b is a positive 6, not a negative number. And my c is negative 10. And as I look at the solution there, I start out with my x is equal to the opposite of b, so in this case that means minus 6, plus or minus the square root of the b squared, so 6 squared, minus 4 times the a times the c, all over 2 times the a. When I start to simplify, I still have that negative 6 on the outside with the plus or minus. But on the inside, I have 6 squared, which is 36. I probably should use a different color. Sorry. I'm going to change up my colors here. So I have negative 6 plus or minus the square root of 36 with the 6 squared. And negative 4 times 1 times negative 10 is positive 40. And then all of that, of course, is over the 2 times 1, which is the 2. And we're going to ignore number 4 for right now and do that on another slide. Next, as I keep simplifying, I have negative 6 plus or minus the square root of, and 36 and 40 is 76. And that's all over 2. And then what I'd want to do is I'd want to see if 76 has any perfect squares in it. Like, for example, does 4 go into 76? Does 9 go into 76? Does 16 go into 76? So I'll check the smallest one first, and I'll see if maybe 4 goes into that. So 4 goes into 7 once, and then it's 36, and that's 19, so it does. And what that means for us is that when I simplify this thing, I need to rewrite it so that I can show that. So as I rewrite it, this means that I really have negative 6 plus or minus the square root of 4 times the square root of 19 all over 2. Because 4 times 19 is 76. Now the reason that you do this is because we know what the square root of 4 is. The square root of 4 is 2. So when I go to keep simplifying this solution, I end up with negative 6 plus or minus 2 times the square root of 19 all over 2. Do you notice how 2 goes into negative 6 and the 2 in front of the square root symbol? You guys notice that? Or in other words, negative 6 divided by 2 is negative 3, and 2 divided by 2 is 1. So my final answer can be written in the following fashion. I can write my final answer as negative 3 plus or minus, and even though we don't see it, there's a 1 here, and then I have the square root of 19. That red 1 you do not have to write, and it's because we saw that the negative 6 divided by 2 was the positive 3, or sorry, the negative 3, pardon me, and the 2 divided by the 2 was the 1. So for number 4, again, I ran out of room, so I'll go to another slide. I'll just go to a whole new one. All right, in number 4, this time we have something besides the 1 for our a. We have 3x squared minus 10x minus 15 equals 0. Which means that my a this time is a 3, not a 1. My b is a negative 10, and my c is negative 15. So again, I like to write those down. That way I know how to use my formula properly. When we write these down in the formula, that means that my x will be equal to the opposite of the b. Since my b was negative 10, my opposite of b will be positive 10, plus or minus the square root of my b squared, so negative 10 squared, minus 4 times the a times the c. And all of that is over 2 times my a. Starting to simplify, I get 10 plus or minus the square root of, huge numbers, 100, minus 4 times 3, which is 12, and negative 12 times negative 15 is going to be a positive 180. Thank you. 180. Holy humongous. And then 2 times 3 is 6. And if I continue to simplify, that means I have 10 plus or minus radical 280 all over 6. So now we go back to this question of, can we simplify that square root symbol or not? So I asked myself, is there any perfect square that goes into 280? First one I'll check is 4, then I'll check a 9, then I'll check a 16, if I can't find one right away. 4 goes into it?
Yes.
Only 4, okay. So if we look at the 4, I will have 10 plus or minus the square root of 4 times the square root of 70? Times the square root of 70. And then that's all over 6. Okay, so then as we work with this, what we see is that the square root of 4 we know, so we have 10 plus or minus 2 times the square root of 70, because the square root of 4 was 2, and that's all over 6. And then I notice that we have 10 divided by 6, which could be simplified. Instead of 10 over 6, we could say 5/3, right? Or, instead of doing both that and the 2/6, there's another way to think about this. What I could do is I could write this as, and think about how this works, 2 times parentheses 5 plus or minus 1 square root of 70 all over 2 times 3. 2 times 5 is 10. 2 times 1 is 2. And 2 times 3 is 6. Sometimes we forget how to do that. No big deal. It's a refresher. And if you struggle with that, I can definitely help you some more while we have work time. As I finish up my simplification, what I notice is that the stuff that we see, the 2's, reduce. So I would write my final answer, my solutions, my roots, my zeros, my x-intercepts as 5 plus or minus the square root of 70 all over 3. And these are what I would say are my x's. Or in other words, where they cross the x-axis. Remember, that means that there are 2 solutions. 5 plus the square root of 70 divided by 3, and 5 minus the square root of 70 divided by 3. Okay, so our last problem that we're going to do is a practical application problem. And it's called the projectile problem. And so in projectile motion, basically what that's talking about is if I were to throw something at somebody else or shoot a cannonball, because of gravity, the object that's being projected or thrown acts a certain way. And it always looks like an upside down problem. So the cool thing is, when we work with this thing, this projectile motion function, is really what we already know. It's the y equals ax squared. But they write things just a little bit differently. Instead of saying bx, they do this thing called v sub 0 x. So we write down a b, like when we generally talk about things. This v0 means the velocity at time 0. And then, in the end, instead of writing down a c, they do plus h0, which means the height at time 0. So this a is actually gravity, and I'll talk about that in a second. The v is what they call the initial velocity, and the h0 is what they call the initial height. Now there's a little bit more to this gravity thing. When you're doing gravity, there are two kinds that you talk about. Well, not two kinds. There's one kind of gravity, but there's two ways they talk about it. Sometimes they use the number negative 4.9, and that's when you're working with meters per second squared. And sometimes they use negative 16, and that's when you're working with feet per second squared. So if you're in metric, you use negative 4.9 for the a, and it's always negative 4.9. And if you're not in metric, it's always negative 16. So let's use this information with the numbers we know for gravity and fill out some information about this word problem. Salvador hits a baseball at a height of 3 feet with an initial upward velocity of 88 feet per second. We're going to let x represent our time in seconds after the ball's hit, and y is going to be the height of the ball in feet. We're going to write an equation that gives the height as a function of time and use negative 32 for the gravitational constant. That's kind of misleading, and you'll see what I mean shortly. When we write down this equation, the equation is going to be y equals negative 16 x squared plus 88x plus 3. And if you're looking for where all those numbers came from, originally we talked about how this negative 16 is gravity, and since we're dealing with feet, that means I use this number back up here from our notes. Second, they tell me that the velocity that I hit the ball with was 88 feet per second, and that's why I have a positive 88 in front of the x. And then finally, they tell me that the ball was hit when it was 3 feet off the ground. That's my starting height, and that's why I have the positive 3 here. So maybe that's another good thing that we could talk about. The y value that you see there, this value, is talking about the height of the baseball at any time. So height is the y. We're supposed to write an equation to find when the ball is 24 feet above the ground. Sounds really difficult, but this is all it means. You just write down 24 equals negative 16x squared plus 88x plus 3. And that's it. And then we're supposed to solve that, but we're not really super familiar with solving equations that look like this. What we're much more familiar with is when it's all equal to 0. So what I can do is I can move the 23 to the